السلام عليكم ورحمة الله. شباب كتسمعوني ياك إن شاء الله. Please confirm. Can you guys hear me?
Yes.
Okay, good.
Yes, we can hear you.
Okay, so this is a continuation of what we covered in the last two sessions. But before we get started, thank you so much for this another opportunity to share my humble experience in the data science in general with my fellow Moroccan citizens. It's a pleasure to be here, and as I said, it's a pleasure to share some of the knowledge that I have. Inshallah ta'ala, if there is a will, we will conduct more sessions, and they are all going to be free, inshallah. So in the previous sessions, we talked about the importance of learning data science. We talked about what is data science in general, why do we need to learn data science, what is the career in data science, and how to build a data science portfolio. And also we talked about the explosion of data, which brought which was the foundation of data science in general and analytics in general. So this is me. My name is Muhammad Midwani, but I go by Mo Midwani, and I'm a PhD candidate doing my PhD in artificial intelligence. I have 4 masters from US. I have probably over 20 years of experience in IT, and I've been doing the data science in the last 9 plus years, doing data science, analytics, machine learning, deep learning in general. So in the previous sessions, we looked into data science from the helicopter view. We talked about machine learning, and today I will dive deep into another subset, another category of machine learning, which is called deep learning. So but before we do that, I would love to go through an overview. It's going to be a very simple overview of what we covered so far, just to guys bring everybody up to speed. So the image you see here, this is the life of data scientist. This is the life cycle, data science life cycle. This is what you might end up doing as data scientist. So a data science project in general starts with a problem that a business is struggling with. And you as data scientist, before you start thinking about designing a solution for whatsoever problem you've been hired for, you need to spend time understand that problem, frame it, transform it into an analytical problem, transform it into quantifiable problem, and find out if it's a problem that can be tackled, can be investigated, and can be fixed using data science. So once you have a clear understanding of the problem and you have the problem being framed, then of course you need to acquire the data, and the data could be ready, available just right at one click. Data could be everywhere, could be scattered across so many resources. So you as data scientist, you have to either work with someone who can acquire the data for you, or you have to acquire it yourself if you have the skills needed for that task. But regardless, you are gonna need the data to design an automated solution for the business problem you've been hired for. And this data here, as I said, it's all about data science in general. It's all about data, and we could fix the problem that the business been struggling with. We could fix it using our initiative, our experience, our past history. We could do that, but most of the businesses, most of the organizations, they are switching to what we call data decision driven. Means they want to make a decision based on the data. In other words, they want to have a solution for this problem using the data, not using the anyone's experience or anyone's initiative, or anyone's knowledge. prior knowledge. So we want to use exactly what the data is telling us. So the data is a critical part of the entire game. We have to have a data, and we have to have it in a certain format, in a certain, with meeting certain conditions, in certain conditions, and with certain assumptions. So that is where once you get the data, of course you need to look into the data and see if there is anything, any way, anyhow to get the data fixed. The data that you would acquire could be probably all the data that you're looking for. It could be less data, it could be too much data, it could be just the right data, it could be a data with so many quality problems. As data scientist, you cannot use that data to make a decision. So you have to explore it, you have to understand it, understand its quality, and you need to prepare that quality. You need to fix whatever quality problems that the data is suffering from. That is very important. So some of the things that you need to apply to the raw data that you acquired. So you could normalize it, you could transform the categorical type of it. There are so many transformation method that you need to apply to bring your data to certain conditions, to a certain format. So you could normalize it, you could integrate your data, you could binarize, categorize, transform category into numeric and vice versa. There is a whole set of different transformation method that you could apply based on your scenario, based on the problem you are trying to solve, and of course based on the data that you have. There is a whole set of transformation technique that you could apply to bring your data to a certain format. So once the data is being prepared, is being fixed, is ready to go, then of course you need to build a model. A model is simply, according to the American, I believe the American dictionary. So the definition of a model is simply a set of steps of rules that the system can, that the system or any computer can apply. It's a steps, it's a workflow that a computer can apply for an arithmetic operation. So it's simply steps of rules that a system can apply to get an output. That is called a model, and there are so many. Actually, that's called an algorithm. There are so many algorithms out there. Depends on the type of the problem they have, and of course, that depends on the data that you have. Some algorithms, they are what we call supervised algorithms, means we already know something from the data, so we can we have an output in the data, we have a target variable in the data, so it's easy. We apply the algorithm on the data to try to map the input on that data to its output. That is called supervised learning in machine learning. And there are some algorithms that are designed for unsupervised learning, means we don't know anything about the data. We don't have we have unlabeled data, so we will design a system that makes an attempt to learn something from the data. Anyway, so there's a lot of modeling that you can build. Depends on the problem that you have, and depends on the data that you acquired. So, but in general, there are four type of learning, four type of directions that you can take: supervised learning, direction, unsupervised learning, reinforcement, and semi-supervised learning. So, regardless of what type of model that you decide to go with, once you build models, you test them. If everything goes good, then you communicate the modeling and the insight, the finding with the management. And if everything goes fine, you deploy that system, that automated system, in production. And of course, the end user will get a report, a business report, or a score, or a decision to make. So this is the day-to-day activities of a data scientist. This is what you will end up doing as data scientists. regardless of the industry you are working for, regardless of the problem you're trying to fix, and regardless of the data that you are trying to solve. Okay, so yeah, just as a matter of fact, there are a lot of what we call methodologies that you could use as data scientist to get you. There's a lot of methodologies that you can get as data scientist to simply get you to monitor the progress of your project. So some of them, one of the most common methodology is called CRISP-DM. It's CRISP-DM, and CRISP-DM is a methodology that used in analytics, and CRISP-DM stands for Cross-Industry Standard Processing for Data Mining. So it's simply a step of a collection of best practices that someone could use from the start of the project, the machine learning project, all the way to the implementation and automation of that system that you designed in production. So this CRISP-DM has 5 phases. The first phase is simply the phase where you spend time to trying to tackle the business problem, transform the business statement or business problem into an analytical problem. It's the phase where you determine the object of the project. You determine it's the phase where you frame the problem, you transform the problem into an analytical problem. It's the phase where you identify the analytic approaches and also identify the team and design your ABT. So I'm not going to go through this because we talked about it in the previous phases, in the previous sessions. So I would recommend that you guys go through the recording. They are available on YouTube in my channel, and of course they are available on the Moroccan IT professional Facebook page. They are available in there. So please go through them, and if you feel like you need more explanation, I will be happy to do a one-to-one session to explain whatever you are struggling with. But this is the process of day-to-day activities for a data scientist. So once you have a clear understanding of the problem, then of course you are going to get the data, and you are going to read the data to whatever tools you are planning to use. You could use a programming language like Python or R. There are the 2 open source great programming languages used in analytics. Of course, you could use other applications. I'm going to name a few. You could use Tableau or Power BI for descriptive analytics, for data visualization in general. You could use RapidMiner, BigML, Salesforce Enterprise Miner for modeling, for prediction, and for diagnostic analysis, and for prescriptive analytics in general. So you are going to read your data, and of course you need to apply some ADA. ADA stands for exploratory data analysis, which is a process that would help you as data scientist to understand your data. The more you understand the data, the more likely you'll design kind of perfect solution. Unfortunately, machine learning goes with garbage in, garbage out. So if your data is garbage, of course you don't expect anything but a garbage solution as well. So once you have the data understood, using ADA or data visualization or statistical analysis, of course you are going to have documented. You should have documented by now any quality problems around your data, and those quality problems is what you are going to fix in the phase number 3, which is data preparation. So you would normalize your data, factorize it, binarize it, standardize it. These are a list of some of the transformation methods that you really don't need to use them all. Use only one, or use whatever transformation that you think fit your data. So you need to bring your data into a format that ready for analytics, to avoid what we just mentioned, garbage in, garbage out. So you might end up, depends on the quality of your data, depends of what problems that the data has. So you could normalize it, you could factorize it, binarize it, standardize it, to simply fix the missing values, outliers, cardinal problems. There is a lot of problems that your data may have, and based on what your data problems have, you could apply so many transformation methods. At the end of the day, you should have a different version, a new version of your data that you started with here. Now you have a ready to go version which we are going to use for the modeling. And the modeling here is what we call machine learning. So in the previous sessions, we talked about machine learning, and in machine learning simply is, as I said, is an algorithm, mathematical algorithm that we apply to on the prepared data, trying to determine a function f, which simply explains the relationship between the variables of your data. So once you determine the model or the machine learning you are going to use, of course we are gonna split the data into 80% or 20% or whatever partition that you decide to go with. So we are going to use one partition to learn the function that explains the relationship between the variables, and whatever we learn from that partition, we are going to test it on another partition that we already have labeled data on it. We already have a target variable. So once we test the model that we learned and the first partition and the second partition, if everything goes fine, then we are ready to implement the solution into production. We cannot simply build a solution on a data and we assume that it's working fine and we deploy it into production. That is not the way it works. We have to test the solution on a different data to see how it works before we determine if we are okay to deploy it into production or we need to do more testing. So in the modeling phase of your day-to-day activities or of your CRISP-DM methodology you are using, you need to split your data, you need to build a model, you need to fit the model or train the model on the first partition, split the data at least into two partitions. One partition should be, is two partitions in here. One partition should be 80% of your data, and the second partition should be 20%, or 70-30 or 75-25. It doesn't matter actually, so you decide. But most of the data scientists, most of the projects that I worked in the past, we use the rule of 80-20. So we are going to train the model on the 80% of the data, and we are going to test it on the 20%, and we are going to evaluate that learning, evaluate how the model is doing on the 80% and 20% before we determine if it's good for deployment. So you cannot build a model right on the fly and deploy it in the model. You might end up losing your job. Okay, so what is machine learning? What is modeling? How these algorithms learn from the data? That is something that we talked about in the second presentation, and I will do my best, just to give an overview of what we mean by machine learning. Of course, before we dive into today's lecture, which is deep learning. So machine learning is simply a child that is out of the curiosity. As you know, kids at the early stage or early age, they try to discover the environment. They don't care if an object is harmful or is it hot or is it cold. They really don't care. So they touch anything, they grab anything, just tasty, put it in their mouth, regardless if it's harmful or not. They don't really care. So this child saw a candle. He saw this candle here, and out of the curiosity, he wants to discover what is this object is all about. So the child put his finger on the flame. So the child put his finger on the flame. So this is the flame here. So the child put his finger on the flame, and of course he got burned. So he got, دار يدو على الفلام وتحرق. So the child then the child learned. No, the child could learn two things from the incident. هاد الرياضي يقدر يتعلم من هاد الحادثة هذه جوج الحوايج. غير إما غادي يتعلم the pattern ولا غادي يتعلم الأوبجيكت. تعلم الباترن يعني if the child learned the pattern, and the pattern is simply anything that is red and shiny and bright really hurts. هذاك يتسمى الباترن. إلا تعلم الباترن which is good. احنا بغينا هذا التشايلد هذا يتعلم لنا الباترن ماشي يتعلم لنا يعني we don't want the child to remember the object. علاش؟ لأن next day إلا جبتي شي object اللي هي حتى هي تقدر كتحرق، إلا ما كانش كتشب الشمعة الدري غادي يحاول يمسها، غادي يحاول discover what is this object is all about. ولكن الدري إلا تعلم البارنتس from the incident، غدا إلا جبتي لي شي حاجة وخا هي it does not look like the candle، وخا هي غير مشابهة للشمعة، ما غاديش يحاول يقرب ليها لأنه عاقل على داكشي اللي وقع ليه البارح. So that is machine learning. So machine learning is a system that we designed to learn patterns from objects, patterns from the data. غادي نعطيوها data وما بغيناش داك السيستم يعقل لنا على الداتا، بغينا يحاول يدخل داك الفاريبلز ولا داك الفاليوز ديال الداتا ويشوف يقلب لي يلقى لنا شي pattern. So the same child here, if he remembers the object next day, the same child will be is walking on the highway or to the kitchen. So he saw this stove top. So the child, because the child remembered anything that is bright and red is harmful. So of course, since the child remembered the patterns, he will not come closer to the stove top. ولكن if the child remembered the object, of course he will come closer because this stove does not look like a candle. هنا فين كاين الاشكال فين كاين دابا؟ الى الدري تعلم لينا الاوبجيكت، يعني الى ما جبتي لي شي حاجه كتشبه الشمعه راه غادي يحاول يقرب ليها. الى الدري تعلم لينا الباترنز، الى جبتي لي شي حاجه with the same patterns راه ما غاديش يقرب ليها. ولكن المشكل الى جبتي لي شي حاجه اللي هي شي لعبه مثلا بحال هذه اللعبه هذه it's a red and of course it's bright. So the child, what the child is going to think, so since he learned the patterns, then he's not going to come closer. إلا جبتي لي هاد اللعبة هادي غادي يهرب. علاش؟ لأنه he already learned that because هاد اللعبة اللي جبتي له فيها هي red and bright، هي حمراء وكتلمع، يعني of course the child, because he remembered the patterns, it is not going to come closer to the object that you just brought him for a birthday or for an occasion. So that is machine learning. Machine learning is simply a system, is an algorithm that we feed the data into, and we have a hope that the system will learn a pattern, and whenever we learn a pattern, we can apply that patterns to any object, any unknown, any future data object. And of course we are going to try to learn to predict the patterns from for that new object. But sometimes that machine learning, sometimes that system can do a serious problem on other objects or other data. So in other words, this machine learning here, they do pretty much a great job in prediction, but in other words, you don't have to we cannot trust them blindly. They are not black box, that we can trust blindly. So they will do a suggestion to us, and we still need to determine if there is something valuable that we can go with, or simply proceed without. So I'm going to stop here. And Brother Shakib, do we have any questions?
Yes, the floor is open to the audience. اللي بغى يسول شي سؤال، اللي ما فهم شي حاجة فممكن تفضلوا تسولوا أستاذ هنايا باش على شي حاجة اللي ما فهمش.
Sure.
سؤال. Thank you.
You're welcome. Any questions?
Any questions, guys?
Okay, so I will take your silence as no questions.
Yeah.
So, okay, so
Has a question.
yeah,
No, thanks. Just keep going. It's great.
thank you. Okay. Just I want to make sure we are on the same page. لكن إذا عندكم شي سؤال، احنا الحمد لله خوت يعني don't be shy، ما تخافش، ما تحشمش، we can always handle it, Moroccan way. So if you have a question, a concern, a doubt, something that's not clear, I will be happy to repeat and to start over. I don't have any problem with that. So I'm going to take your silence as no question. So to learn from, to help the machine learning learn. So number one, we are going to feed, we are going to have a data. So let's say that we have 6 million records. I'm going to use a board. So let's say that we have I'm going to simply try to design a very small data set. So let's assume that we have a small data set that looks like this. So we have data, simply small data. Okay. And in data we have few variables. Let's say that we have age, we have let's say marital status, married, not married, single, divorced, etc. Hour spent, and we want to see if this, so this is for student data, and we want to see if the students will graduate. So we have graduation, yes, no, and this is something that happened last year. So let's say we got 20,000 students. We got 1, 2, all the way to 20,000. We got age 19, 24. We got let's say 21, single, married, single. This guy here is spending, let's say 7 hours a week. This one is spending 5 hours a week. This one is spending 17 hours a week. This guy no, did not graduated. Okay, so this is a very simple data that we could use for machine learning. And they hired you as data scientist, and that this has happened in let's say in 2020, and of course here we got another 40,000. We got 40,000 students that we have the same data on them. So we got we have their age, we have their marital status, we have their hours spent on and their education. Got some numbers in here, and we want to predict, they hired you as data scientists, and we want to see if they will graduate towards the end of the program, or towards the end of the year. So this is a problem that can be solved using machine learning. So with machine learning, we are going to build for the machine learning to learn. As I said, let's assume that we have 20,000 students, that we have their past history, and then we know that they are they are labeled, means we know their end result. So this is called target variable. So what for the machine learning to learn, it needs three type of data. Needs three type of data. We need a data. We need a data. I'm going to simply put D here for data that we know. As know plus machine learning. So we need the data that we know it's a graduate and it's not graduate, and we need the machine learning needs a data that only we as a human we know the end, and we are going to need data that is not known to both of us. So I'm going to explain these three concepts. So the way this machine learning works is we are going to split this data into 80% and 20%. Okay, so when we split, let's assume that we are going to have, this is our 20%. Out of this 20,000, so this is our 20%. Sorry guys, I'm not a good artist. I'll try to make a good table as much as I can. So my apologies. So of course we are going to have age, we are going to have marital status, and we are going to have our spend, and somewhere we are going to hide the end result. So this one is going to be graduated, yes and no. And of course for every student we have 1 or 0. 1 means graduated, 0 means they didn't graduate. So the machine learning needs three data to learn, three type of the data. The first type is a data that is known to us as a human. We know the variables, and we know the output or the target variable. So the machine learning knows it, we know it. That is called 80. So this is 80%, and this 80% is called a training. It's called in machine learning training set. So we are going to build. We are going to the model will be trained in this 80%. So we are going to train the model. We are going to get the model to learn the patterns in terms of graduated, yes, no, equal a function of age plus marital status plus hourly spent. So this is the function that we are trying to learn using the machine learning. So once we learn this function here, there are so many different ways to learn these functions, but we're trying to find the optimal function that could map these variables, variable 1 and 2 and 3 to the target variable. So once we learn this function here, we are going to test it on this data that we know it, but we are going to hide the target this variable here from the machine learning, from the algorithm. So this function here that we learned on 80%, we are going to test it on 20%, and of course when we test it, the machine will come back, will create another column. It's called predicted target variable. It's simply a prediction of this graduated yes and no, and of course it will have values either 0 or 1, 0 1 0 0. And the way we evaluate if this machine learning is doing better, we are going to compare the predicted target variable of this machine learning, or the column that the machine learning created on the 20% with the actual target variable that we hide it from the machine learning, and see how closer they are. If they match 100%, that is what we want. If they match 100%, that is simply means that the model is doing great. This function that the model learned on the 80% is doing great. So now we are ready to apply it on a data that it's not known to us and is not known to machine learning, a data that's going to come tomorrow. So this data here is in production. So this is how machine learning in general learns. So we are going to learn, we have the machine learning here, and it could be supervised learning, machine learning. It could be unsupervised learning, machine learning. It could be reinforcement, machine learning. It could be also semi-supervised learning, machine learning. There are so many different machine learning that we could use, but this is all the same probably methodology used to train a machine learning, to train a model. So we are going to train a model on 80%, or a data that is we know with the machine learning knows it. Then we are going to test it on the 20% where we know the data, but we are going to hide something from the machine learning to see if the machine learning will come up with something similar to what we already know. So we are going to compare the two data, and if everything goes fine, then we are ready to deploy into production. So comparing the predicted target variable to the actual target variable is what we call scoring, or it's called accuracy, how accurate the model is. So that is how this machine learning learns. So we split the data. We split the data into 80% and 20%. We split data in 80% and 20% is the same data. You could have 6 million records, 10 millions, and 500, it doesn't matter, but we are going to split into 80%, 20%, and we are going to use machine learning on the 80% to learn the patterns. We are going to use machine learning on the 80% to learn the patterns, to learn a statistical model or patterns in general, and we are going to use this pattern here. We are going to test it on 20% to see how the model is doing, and if the model is doing better on the 20%, that simply means the statistical model that we learned on 80% is good, and now we are ready to deploy that into a new data into production. So there are, as I said, there are different type of learning: supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, and active machine learning, and of course they might have other learning, because this is an evolving discipline. In a couple of years you could get different different type of learning. So in our daily life as humans in our daily life, we make a lot of decisions. Every day you make probably a couple of hundred decisions. Before you go to bed, do you sleep in the right side or left side? Do you need to sleep in the in the room number 1 or number 2, or do you need to sleep at 12 o'clock or 1 o'clock? You make a lot of decisions. Every day we make a lot of decisions, in our daily lives, and those decisions, they are based on something. So we could make a decisions based on some information that we have. Like for example, you want to go for pursue a degree, a master degree in data science. Do you need to go, for purely data science, or a machine learning, just pure machine learning? So you need to have some information to make that decision. That is called information-based learning. We are making a decision based on some information that we already collected. Sometimes you make a decisions based on some similarities. Now you want to see, I have friends, I drive, I am a smoker. I am not, but let's pretend that I'm a smoker, and I have friends, and you want to make a decision on them. You want to see if they are good or bad. So because they associate with me, most likely they are going to be smokers also. So you are making some decisions based on similarity. Sometimes you make a decisions based on some guessing, some probability. Do I need to go for a picnic with my family? We are going to guess, what is the probability is going to rain. If you have a higher probability, of course, you are going to make a decision not to go for a picnic, not to go for an outside event. Sometimes you make a decisions because we had a bad experience. I was driving 80 hours per 80 miles per hour. I got pulled over. I got a ticket. Next day, of course, I am not going to drive 80 miles per hour because I learned from my error, from my mistake. So these are some of the ways that we as a human make decisions for our daily activities, for our daily life. So the machine learning that we try to design, we try to design some type of machine learning that can mimic our behavior, mimic the way we make decisions. So we want to make this machine learning that can learn from the data based on the information on the data. We could use machine learning that can help us to make a decision based on some similarities and the similarities in the data. We could use machine learning to help us make a decision based on calculating the probability of an event to occur or not, for an event occurring event or not occurring event. And we could design a system of machine learning that could help us make a decision based on some errors. So of course we have so many machine learners that can do this. For decision information based learning, decision tree is one algorithm that can make a decision, can learn from the data using what we call information gain or information based learning. Random forest is another one. Bagging families and boosting families, or this type of models or models they learn based on information based learning. Models that learns from using similarities, calculating the distance between the variables of your data. KNN, K nearest neighbor is one of them. Simply uses the distance to determine if an element is closer to a different element. I'll give you an example on this. So let's assume that just an example of KNN, how this KNN works. So let's assume that we have a small data set that looks like this. So we got here a small data set, and so let's say that we have here country names, country populations, and country how danger going visiting, and let's say that should I visit yes or no. So we got here, let's say we got India, we got Sweden, let's say that also we got another, we got Mexico, and we got Morocco, for example. Okay, so here let's assume that we got 120 millions. I know there are a lot. I know there are a billion. Sweden we got 20 millions. Mexico we got 15. Morocco we got 15 millions of population. Just let's assume. I know the numbers, they are higher than that. Dangerous. This is okay. Let's say that dangerous from 0 to 10. 10, no, most likely you are gonna be killed. 0, it's safe. India, let's say we got 9, and Sweden we got let's say 3. Mexico 7. We don't know about Morocco. And of course, visit yes. We could do yes and yes, and we don't know about Morocco. Okay, so now the model learns using Euclidean distance. So we want to determine if Morocco is safe to go visit or it's not safe. So using this type of data here, of course we are going to compute the distance between the mathematical distance between India and Sweden and Mexico and Morocco. So using if we were to use a CP or country population, of course the closest or the most similar country to Morocco is Mexico. And since Mexico is 7, Morocco most likely is going to be 7. So we just learned, now of course using some mathematical behavior here, now models learns using the mathematical behaviors. So since Morocco is similar to Mexico, so Morocco most likely is going to be a 7. Most likely is going to be a 7. So it's dangerous to go to Morocco. That is type of learning is called similarity-based learning. We we memorize a position of a data within a position of an element within our data, and when you give us a new element that we want to determine its value, so we compare it to something that we already have in the data. We're looking for something that is similar to it in the data, and we make a decision based on that. So that is similarity-based learning. Probability-based learning is simply calculating the probability of an event either is gonna occur in an event to occur or not occur, and based on that we make a decision. Sometimes we make a decisions based on the error. So for the machine learning, as I said, decision tree is a machine learning that can learn using information. KNN is another machine learning that can be used to learn using similarities. Probability, we could use logistic regression for classification, and also we could use naive based, and error based learning. I believe we could use support vector machine, and of course there are other models that we could use. Depends on the type of the methods that we use to make a decisions. So let me stop here for a second, and let me see if you guys have any question, any concern. Any questions, any concerns, any doubt about this?
Anybody has any questions for Mo? We gotta hear some voices, guys. Alrighty.
I think this is good. Thank you. Bismillah.
Thank you, Asma.
Hey Asma, you have a question? Asma, do you have a question?
No, I don't think she had a question. She said it was clear.
Good, okay. So I'm going to skip some of these. Yeah, these are some type of modeling. Let me grab the highlighter. So yes, as I said, depends on the way we make a decision, and depends on the way the model that the decision that we want to make. We could use a hybrid. We have married a list of techniques that we could use. Decision tree is one of them. Kernel method, dimensionality reduction, association rules, INN, Bayesian method, clustering method, ensemble method, instance-based method, regression analysis, and these are type of learning. Of course, we don't have time to go into details. There's probably, if you guys want to schedule another meeting, I'll be happy to do it, to go through much details on each type of learning, type of modeling, or type of algorithms that we have here. So once we learn, once the model makes a decision, before we deploy that decision into production, before we decide to use it to move it into production environment, of course we have to test, we have to evaluate the value, evaluate the performance of the models. So it depends on the model itself. Some models we could use, like in regression models, we could use R squared and root mean squared error. So these are some of the type of the measure how good a model is, or how good what we learned is before we deploy it into production. And if you are doing classification, which is another type of learning, there are long list of different measurement that we could use to determine if the model is good or bad. So we could use precision, recall, confusion matrix, person correct classification. We could use accuracy, just name it. In the clustering, we could use within sum of squared error, of course, and there are other techniques. So that is machine learning. That is machine learning in general. That is how the way the machine learning learns from the data, how to test what they learn from the data and a different data that we already know, but it's not known unto the machine learning, but we know it. So we want to see how this machine learning behaves on the data that we know, and we evaluate the behavior using different techniques. So once we are confident enough that the machine learning is doing a good job, then now we are ready to deploy it into production and let it do the work for us. So now to today's topic, and we are running out of time, unfortunately. We are going to talk about deep learning. Deep learning is very simply is a subset of machine learning. Is a subset of machine learning. That is deep learning. Is another advanced, I would say, advanced machine learning. So the difference between machine learning and deep learning is, number one, machine learning, they are used most likely for some simple problems. Deep learning, they are used for complicated nonlinear problems, like image processing. One image could have thousands of variables when they transformed into pixels, and so there could be 1,000 of variables. So machine learning would not be able to handle that number of variables for one single object. So machine learning, they are used for some linear or non-linear, very simple problem, and deep learning, they are used for complicated, complex problem. And also in machine learning, you have to tell we have to prepare the data. You have to reduce the dimensionality. If you have a data that has 6 million records and you got 300 rows and columns, of course that is probably that would create a lot of problems for the machine learning. And the machine learning we are trying to use might not learn a pattern, might not learn anything, because we have so many features to learn. So we have to reduce those. We have to eliminate some features. Eliminating some features or excluding some features from the learning, that is what we call dimensionality reduction. So we as a human, we need to get into the data and determine which features should be included and which features should not be included. Another example, in the example that we talked about, so all these features here, that might be good, that might be, we don't know yet. So we got here x1, we got x2, we got x3, and we got the y. So which x should be used? Do we need to use only x1 to determine the value of y, or could we use a combination of x1 and 2, or we could use all three of them? Which one we know? What is which x that we should include in the learning, and which x should not be included? Three of them, they are probably we could use all of them. But what if you have 40 or 400? Do you need to use all of them? Of course not, because they could slow the computation. They could slow the learning. They might not get you anywhere, since the patterns will be scattered across 400 features multiplied by the values. If you have 400 and you got 1,000, then 400,000 variable. So it's a lot for machine learning to handle. So for a machine learning, we need to determine which features, so they call features, x1, x2, x3, or feature 1, feature 2, feature 3, which feature that we need to keep and which feature that we should not keep, of course using some scientific method. So we have to determine if a feature should be kept or should not be kept. And in deep learning, it does not work that way. Just feed all the features into the model and it could do the job for you. So in machine learning, we try to mimic the human behavior when making decisions. So we make decisions based on information that we have. We make decisions based on some comparison that we made. We make decisions based on some probability, some calculation that we made. We make decisions based on some past experience that we had. So we designed most of this machine learning to help us to mimic this human behavior. And deep learning is also a method that we use to mimic the human brain, how we think. So this is a biological neuron. This is what is in our body, and this biological neuron, the way it works, so it's called the cell or biological neuron. So it has some connections. They are called dendrites. So it has some connections. Come on. Sorry guys. So it has some connections to the outside. So this is where the information is coming in using our 5 senses: the smell, the sight, the touch, the taste, the hearing. All the information, they are coming, and they are gathered, and on the heart of the cell is called nucleus. So this is the heart. This is where the magic is happening. So once the information is pre-processed, of course a decision will be made, and that decision will be carried out to another cell, or it could be carried out to either another cell for further pre-processing, or it could be the final decision. So it could be carried out for another cell for the pre-processing, or it's going to be final decision. So we want to design a system that mimics the human brain, how we function. So we want to design a system in the future that the system would smell, would have the ability to smell, ability to recognize, ability to see, ability to hear, ability to make a decision based on the touch. So in the future, that is where we are heading with this artificial intelligence. So in the future, 5 years from now, and probably they already have them. So robots, we could have some robots that could act exactly the same way that we do. They could make a decisions based on what they see, right in the fly. They could make a decision based on what they smell, what they hear, what they touch. But this is the biological neuron, and this is what we're trying to design. Some characteristic of this biological neuron. So this is the real one. So this is the real one here, and these biological neurons, we have over 100 billion of neurons in our bodies, and some of the neurons, they are connected up to 1,000 connection. So in other words, when we got the information transformed into one cell, the cell will do some pre-processing here and send the signal to another cell, which will do different pre-processing. Then that cell will be connected to a third, a fourth, a fifth, up to 1,000. So we have 100 billion cells in our bodies, which could be connected up to 1,000 connections. So is there a way we can design a system that can mimic the human brain? And that is what we call deep learning. So few things to remember about biological neuron. The biological neuron, they can deal with incomplete data. So our brain can deal with incomplete data. I'll give you an example. If you were driving in a highway at night time, in the midnight, and you were driving, let's say 90 miles per hour, and from a long distance you saw a blue light from somewhere, but without knowing it's a cop, you will definitely reduce the speed to 70. So you made a decision, even though you don't have a complete information of whether the light is coming from a cop's car or it's a pharmacy light or something else. So the biological neuron doesn't make decisions either if the information are complete or incomplete. So also the biological neuron, they process the data in a parallel way. In other words, you could be driving at 90 miles per hour and talking to phone to your wife and listening to the music. So you've been doing three things at the same time, and your body will get all the information from three things at the same time. So that is called parallelism. And of course, it's our biological neurons, they learn and adapt. The moment you see the light, of course you are going to adapt to the scenario, what you call the future state. So the moment you see the light, you are going to degrade the speed. You are going to reduce the speed to 70. And once you pass the light, then you are going to go back to 90. So this is the four criterions as we understand them of the biological neurons. And we want to design a system that do the same thing to us. We want to design a system that can handle incomplete data. We want to design a system that can do some parallel processing. We want to design a system that learns and adapts. And we want to design a system that degrades gracefully. And that is where the INN or the natural language comes into the picture. And let me stop here. And see if you guys have any questions. And we might need to stop here because of the time. Questions, concerns? Okay, folks. So I really believe we should stop here.
I have a question.
Yes, ma'am.
What do you mean with incomplete data?
So incomplete data is like if you have a data that you have some missing values. Like for example, let's say incomplete data. Let's say that you want to determine if a student will graduate based on some behaviors. And let's say that we have a small data set that looks like this. So you got you got age, you got marital status, you got hours spent in studying, and so this is a history. And we got, did the students graduated? Yes or no? So we got student 1, student 2, and student 25,000. Okay, so we got age 19, and this one we don't know the age, we don't have the information. This one we got age 25. We got here marital status, married, single. Hours spent, we don't know. We got here 77. We got here 11, 0, 1, 1. So as you see here, this is incomplete data in terms of we don't have information on how many hours spent of student number 1. we don't know the age of student number 2. So that is what we call incomplete data or missing values in general. Do we build, can we still use this data here to learn the relationship between x1, x2, x3, and y? Yes, we can, but we have to find a way, we have to find the optimal way to handle these missing values. So our brain can make a decision even though it's incomplete. You were driving, as I said, at midnight, then 90 miles per hour, then you saw a blue light. You are not sure if it's a cop or not, but even though, regardless, you are going to make, your brain will tell you need to reduce the speed. So our brain has the ability to make a decision even though there is no much information, and we want to design a system that can mimic how our brain function in that scenario. So this is another scenario that we don't have. We have a data, but it's an incomplete data, and we want the system to still use it even though it's incomplete. Is it clear?
Yes, thank you.
You're welcome. Okay, folks. So
Anybody has any questions?
yes.
No, I'm just asking. This is Shakib. I was just asking Mo. If anybody has any questions.
Yeah, this is Rashid. I'm just wondering, maybe it doesn't have to do with this class, but it's part of artificial intelligence. My question will be, you mentioned that artificial intelligence, it has to do like, it's like learning as a human, right?
No, mimicking the way the human learns.
Right. And in the future, the point is to be better than human in the future, right?
We will never be better than a human. I know for sure because we designed them. So we are, as a human, we are better in patterns recognition, and the machine learning, they are better in calculation. Of course, if you give me 5 times 20 times 100 times 3000 divided by 70 times 35,000, I will not be able to do it. The machine learning will do it better than me. But if you give me a cat, I will tell you it's a cat. So we are good in making decisions based on the patterns, but we are very bad in making decisions using those calculations. The machine learning, they are the otherwise. They are good in making decisions based on mathematical operations or calculations, and they are bad in making decisions based on the patterns.
I'm just wondering if this is, maybe it's now, but the point in the future for machines or robots to replace humans.
Yeah, I see your point. As I said, in the future, we really don't know what's going to happen, but we are going that direction. We could end up designing some robots that could simply learn on their way. They learn how to make decisions, and at that point, is going to be some really serious problem from humans. I'm going to be we could fight with them. So I think regardless of where we are heading, there are always going to be some controls in our design. So if we design our robots, we have to have in the design some way to control them. And they will never be better than us because we designed them, we created them. So that is simply the way I look at it. But of course, I may be wrong. 5 years from now, we could have upside down. Robots controlling humans. So we could be a slave of the robots. So we act. We work for them. Now we design them to work for us, but we could end up working for them. You never know. You never know. Okay?
All right. Anybody has any questions?
Yes, I have a more specific question. I am wondering how, I have a biology background, I'm wondering how this can work for biological data.
So yes, I mean, data science would work for any problem, regardless of industry, as far as you have a data. And as a matter of fact, data science is a really good fit for biology, for healthcare in general. So if you are in that field, I would recommend that you learn data science. It will open so many doors for you.
Okay.
Yeah, just learn it. It will help you in the future. So knowing biology is the main expertise. All what you need to add to be to open so many doors or to have a lot of opportunities is learn data science and use it in that discipline, and you could end up working for healthcare industry using your biology knowledge, and using your data science analytics experience.
Okay, thank you.
Yeah, welcome. Other questions, concerns?
There are no more questions.
Sorry guys, next session, I really don't mind you guys having another session, and next session we go straight to the topic without doing any review of what we covered. My sincere apologies. So I really thought we could be done in 1 hour, but it looks like not the case. So I'm willing to do another session, which is going to be an introduction to deep learning part 2. So this is part 1, and we'll do part 2 either next weekend or the following weekend, whatever works for you guys. I will be happy to run an extra session to cover this topic.
Thank you so much, Mo. This is very valuable and very good information. And thank you so much for your time.
You are welcome, sir.
Yeah. So if we don't have any more questions, I'm going to go ahead and stop the recording so we can have the video. Any more questions so far? Shifa, Fatima, Zara, Lamia, Nasima, Rashid, Siham, Wala. Any questions, guys?
No, I'm all set. Thank you so much. You explained it very well.
Okay.
Yeah, welcome.
Thank you. Thank you for your time.
Okay, assalamu alaikum.
Assalamu alaikum.
Thank you.